Oh, can you hear me? Okay, I think it's working. So, but I think so. Actually, in the previous semester, I used the microphone of this USB microphone, but I think now I need to use the microphone of the webcam. So I believe the audio quality may be worse than the previous semester. So I need to check. Sorry about this inconvenient situation. So yeah, so today is the first day of this course, and then welcome to the computer architecture course. This course is the basic computer architecture course for undergraduate student. So this is the very basic course regarding the computer systems, computer hardware, and computer architecture, system architecture. So I believe this is the mandatory course of the computer engineering and the computer science department. So I believe many students must, should take this course because this is a mandatory course. But yeah, but I think this computer architecture course is very important to the computer engineering student because the computer system. So actually, we use the computer system every day and then every time actually. So, and then also that means that the software runs on this computer system hardware. And then if you want to be a good computer scientist or a computer engineer, computer related engineer, then you need to understand how computer works and how the computer program or software works on the computer hardware. That's why this course is so critical. That means so important for the computer engineering or computer science student. Okay. Yeah. So welcome to the course. So this is the first time of this course. So I will briefly introduce about this course. Okay. So course description. What is this course? So and then what is the goal of this course? So in the one sentence, the goal of this course is exploring computer system architecture at an abstract level. So I believe most of students are the second, that means the sophomore student, that means actually the second grade. So it's called the sophomore, right? So I believe everyone knows it's a sophomore student, 2학년이요, 대학교 2학년. So this course is provided to the for the sophomore students. So actually the goal of this course is exploring computer system architecture at an abstract level. So you need to focus on the abstract. So have you ever heard about the terminology abstract? So I think it's not easy. So actually the lack of interaction between instructor and students is the disadvantage of this online classes. I know. So actually we will learn about the abstraction level or abstract level and I will, this is the next class. So actually in the computer engineering or computer science field, this abstract is very important terminology. But this abstract or abstraction is widely used in our normal life, okay? Because we cannot understand everything. We cannot understand some complex theory or complex systems in our real lives. So actually, we just understand the required things, the required part of that is complex systems. So actually the computer systems are very complex, so complicated, so everyone knows. So recently the CPU has billions or trillions, and then some chips has the trillion transistors. So that means that the computer systems are very complicated, very complex. We cannot understand every part or every aspect of the computer system. It's very difficult. So we just understand the abstract level. So that is the simplified, where some actually the essential part, and then only the some essential part is only required for understand how the software works and how the computer system works. So that is the kind of abstract. So go over this course, exploring computer system architecture at an abstract level. So that means the simplified level, not everything. Okay, so what will be covered in this course? The basic concept of computer systems. So I mentioned that we will learn about the computer systems or computer system hardware, not software, but we will also cover some interfaces between hardware and software. So that means you need to understand also some very basic of software, especially C programming. Okay, so we will cover the basic concept, not everything, basic concept of computer systems. Okay, and then what is the basic concept? What are the basic concepts actually? So performance metrics. Why do we need to understand the performance metrics? So we need to compare which computer is better or which computer is worse. That is related to the performance metrics. So we need to measure some performance metrics or performance numbers of the computer systems in order to develop the good software or good hardware of the computer systems. Okay, and then instruction set architecture. It's very, very, very important. So this instruction setup. So have you ever heard about the instruction set architecture or ISA? Yeah, okay. So this is the first day of the course, okay? So instruction set. So we will learn about the instruction set architecture. That is that defines the basic instructions which can be understood by computer hardware. Okay, so we know that the computer system works with electric power, electric systems. So it's a kind of electric systems. So that means the computer hardware only understand the electric signals. So actually, every instructions or every data should be translated into the electric signals or machine code. So we will learn about the instruction set architecture, and then it's called the ISA, and then machine languages. And then arithmetic logic, number systems. So I mentioned that computer handles the data, and then actually every data is related to the numbers, number, okay? Because computer can only understand some number systems. So we will learn about how the default basic component of the computer hardware works. That is called the arithmetic logic. And then we will learn the number systems used by computer hardware. Okay, but it's the kind of a review, because if you took the what's that? Digital logic design course, it's COSE 221, 211, 221. And actually, this number systems or arithmetic logic design is covered by this digital logic design course. It's actually prerequisite course of this computer architecture course. Okay. And then we will learn about another process architecture or the pipelining. So important. The pipelining architecture is the basic architecture of the computer hardware or CPU or some actually the every digital system, so digital hardware. So this is very important. So we will learn about this pipeline architecture. And then memory hierarchy. Right? So I mentioned computer handles data, and then data is stored in the memory, like RAM or storage system. So, and then in order to process this data should be stored in the memory systems. Also, this data is transferred to the processors like CPUs. So this memory system is also very critical for the performance of computer systems. So we will learn how we can organize the memory systems or memory hierarchy efficiently in the computer systems. Okay. And then, so additional topic is the parallel processor architecture. Okay. So these are what we will cover in this course in this semester. So, and then textbook. So I will use this textbook. It's a computer organization and design, and then RISC-V edition. So actually in this course, we will cover the RISC-V ISA, is an instruction set architecture. So you need to purchase this textbook, RISC-V edition. So actually there are 3 different editions for this textbook, like MIPS edition and ARM edition, and then RISC-V editions. RISC-V edition is the most recent RISC type instruction set architecture, and then this is the open source ISA, the instruction set architecture. So actually, many people in academia and industry have interest in this ISA because this is the open source architecture. So what is the most popular ISA in our world? ARM and x86. So actually for the laptop computers and then desktop computers, we normally, so we usually use the x86 CPUs. That means that manufactured by Intel and AMD. So that means these CPUs implement x86 ISA instruction set architecture. So that means because Intel CPU only can understand the x86 type ISA, not ARM ISA or some other different instructions. And then for the smartphone or some embedded systems, ARM ISA is the most popular ISA. So our smartphone like iPhone or Samsung Galaxy series use the CPUs, and then these CPUs can understand only ARM instructions. So that those are the 2 most popular instruction set architecture in our real world. But we will learn about the RISC-V ISA because this is the open source architecture, and then it's very also it is getting more popular in the academia and industry. Okay. So please purchase this textbook. So actually, I will announce later. But if we take the online exam, like using Zoom or some online systems due to the COVID-19 pandemics, then the exam will be open book exam. Okay, so you will need the textbook. Okay, so please purchase this textbook. Okay, and then course materials and tools. So actually, I will upload the lecture slides. So we will use the lecture slides like this. And then this course has a design labs. And then for this design labs, you will be required to design RISC-V, very simple RISC-V pipeline processor. Okay, you will be requested. Okay, and then for this design labs, we will use the model sim. That is the RTL simulator. It's called the, and then this simulator is used for actually digital system design. So we will use the free version of the model sim simulator, and in the bundle of the Intel FPGA Start Edition. Okay, and then it is required for lab assignment. Okay, also for this course, I will use the RISC-V architecture simulator for your better understandings. Okay. Authors. So actually, this textbook is very popular. I also learned with this textbook is a computer organization and design, and it's actually the first edition is the MIPS edition. So I learned with the MIPS edition of this textbook. So actually, this is a very popular textbook in the computer architecture field. So this photo shows the authors of this textbook. The authors are David Patterson and John Hennessy. So those are the recipients of the Turing Award. So that's the kind of Nobel Prize of the computer engineering field or computer science field. So very popular. Okay. So these are the author of the, and then also these they invented RISC type architecture. It's very, very, very important architecture. And then actually most of CPU currently use the RISC type architecture. So they invented this RISC type architecture. So those photo is the so very old photo. So currently, so they look like this. So he's David Patterson, then he is John Hennessy. So this is the photo from the ISCA 2018 Turing lecture. Okay. So if you are interested, then you can click this link. Then you can watch the Turing lecture video. It's a very, very great. So this video is very great. Okay, prerequisite. So what is required? So as I mentioned, so we will use the actual HDL. It's a audio description language, and then actually for this our design lab, we will use the system Verilog like this. So system Verilog is the one of our audio description languages. So then if you did not take this digital logic design course, then you maybe did not use this system Verilog language. So you can feel that, oh, this is somewhat difficult. So it's a recommendation, but so actually we cannot cover the knowledge of this audio description language or some design, hardware design or some digital design in this course, because you need to learn actually many things in this course. So I cannot cover the digital logic design related knowledge in this course. So if you did not take this digital logic design course, then please be prepared and then study by yourself, and then please be prepared, okay, before the design lab. Okay, so digital logic design. Also, so I mentioned that this is the hardware course, so we will learn about some basic concepts of the computer systems, but computer is composed of software and hardware. So that means actually our program, it is called the high-level program, is executed on the computer hardware. So that means we need to also understand how our programs run on the computer hardware. Okay, and then for this, in order to understand some computer hardware systems or system-related operation, it is good to understand the C language. Okay, so that means it is because the C is the kind of high-level languages like Python, but C is it's a slightly lower level of the Python. Okay, so that means the C can with this C language we can use the pointer. So that means actually this pointer is very similar to the address of the data. So I can use some concept of this pointer or concept of the C language in this course, right? Okay, so you may need some knowledge regarding the C language, not Python, because the Python is so C and Python are different each other. But that means the C is the compiler-based language, and then the Python is the interpreter language. So it's a more higher level, but so actually Python is easy to use and then easy to understand, but it's a high level. Okay, it's an interpreter, not compiler-based language. Okay. Okay, instructor. So me. So my name is Konjae Koo, Konjae. And then so my office is Ujong Jongdogan 43. And then so office hour, but if you cannot use this office hours, then you can visit my office by appointment. Okay, so if we can talk using Zoom. Okay, then this is my email address. So if you have any concerns, then you can email me anytime. And then my webpage, and then this is the address of my lab page. Okay. So recently I made the homepage of my lab. So if you are interested, then you can visit my webpage and my lab homepage and research area. So generally computer architecture. So that's why I teach this computer architecture course. And then in the computer architecture area, I have interest in memory storage systems, neural network accelerators, and GPU architecture and RISC-V architecture. Okay. Course web page. So we will use the Blackboard. So everyone uses the Blackboard. So this is the address of the Blackboard. And then actually I will use the Blackboard for announcements and assignments, the homework assignments. And then lecture slide, I will post the lecture slides on the Blackboard. And then for discussion or questions, I will use the Piazza. So Piazza is also a kind of a course management tool. but this Piazza is widely used in the academia in United States. So if you have any questions or if you have any issues and for the lab assignments or homework assignments, then you can post your questions on Piazza. So it's easier than the Blackboard, easier to use than Blackboard. Okay, that's why I use Piazza. Okay, so this is the access code. So if you visit the Piazza via this link, then you need to sign up on the Piazza, and this is the access code for this course. Okay, please join as a student, and then post your questions and discussions. And then if you post questions or some issues on the Piazza, then anyone can answer these questions. Anyone. I can answer, TAs can answer, and then other students can answer. Okay. Also, Piazza also provides the mobile app. So you can use the Piazza mobile app. Okay. So like this. So this is the screenshot of the Piazza, which used for the previous semester. So you can find maybe the last year. So you can find many questions. And so for every questions, TAs or I answer for these questions. Okay. So unfortunately, we are amid COVID-19 pandemic still. So this is the Zoom information. And then, so I think everyone registered for this Zoom meeting. So actually, you need register your names or student IDs, and then these names and student IDs are used for attendance check. Okay, so you need to check in with the correct student ID. Okay, so actually after every Zoom class, I collected these student IDs collected by Zoom tool, Zoom meeting room, and then I check the attendance of the every students. Okay, and the recommendation. So please actively participate in every class, and then actively participate in these lectures. And then, so I know that this is not easy. So actually making the two-way conversation, that means it's not easy using the Zoom meeting tool, but please actively participate in the every class, okay? And then this is a recommendation, but please turn on your video camera, because so I know the privacy is also important, but in the previous semesters, I allowed the students to turn off these Zoom videos, but I don't know if they focused on my lecture or like the classes or not. But if you turn on your video, then I can know, so students can focus on my lecture. So and then yeah, so I can check the students are study hard during the classes. So please turn on your video camera. I know that everyone now turns off the video camera, but please turn on your video camera. Okay? 네. 굳이 이제 좀 설명하자면, 네, 어쨌든 뭐 줌으로 하다 보니까는 어쨌든 뭐 프라이버시도 중요하고 뭐 학생들이 비디오 안 켜는 것도 뭐 다 이해를 하고 그 그러고 싶지 않은 것도 이해하지만 어쨌든 집중하는 게 중요하다라는 생각이 듭니다. Just you need to focus on the lecture during the Zoom session. 어쨌든 이게 1시간 15분을 투자를 하는 건데 하려면은 좀 포커스를 해야 되고 뭐 저도 뭐 자녀를 키우는 입장에서 비디오를 끄면은 뭐 딴짓을 하더라고요. 어쩔 수 없이. 예, 예, 뭐 참 사람이라는 게 마음대로 되지 않는 것 같아서 예, 뭐 가능하면은 so it's a recommendation. Please turn on your video cameras in every classes. Okay, and then this is grading policy. So the percentage is the tentative, and then exam. So actually, the on-site exam we plan the on-site exam is some offline exam, but cannot we don't know how the COVID-19 situation. So we can take the online exam. If the COVID-19 situation is still severe, then we need to take the online exam. And then for the online exam, it's the open book exam, not closed book. So if we take the on-site exam, then the exam will be closed book exam. But if we take the online exam, then it's the open book exam. Okay, so that's why I want every student to purchase the textbook. Okay, so and then you in the exam you can answer in Korean or English. So this is the English course, but this is the using English is my duty, not students' duty. So if you have any questions, then you can ask questions in Korean. So if you are a Korean student, okay. So schedule. Okay. And then actually in the September we have Chuseok holidays, so we will have no class in on September 20 and September 22. Also, actually the October 4th and October 10th are the substitute holidays. So, but class will not be cancelled on these substitute holidays. 대체 휴일이긴 한데 so we are student as you are student. I'm an instructor. So you are student. So these substitute holidays will not be applied to students and teachers. Okay? 그러니까는 10월 4일하고 10월 10일은 수업합니다. 이거 뭐 그냥 정부에서 대체 휴일로 하긴 했는데 그러면 우리가 너무 많이 빠져요. 너무 많이 빠지기도 하고 그리고 사실은 대체 휴일은 이게 퍼블릭 할러데이라는 뜻이 사실 공무원들 쉬라고 이게 법적으로는 그렇게 돼 있어요. 법적으로는 공휴일, 공무원 휴일이라는 뜻이라고 하더라고요. 그래서 10월 4일하고 10월 10일은 수업합니다. So we will miss 2 days during Chuseok holidays, and then we will have classes on October 4th and October 10th. Okay. Do you have any questions regarding syllabus? Okay. 질문 있나요? Okay. 이제 어, 10월 9일이 한글날, 네, 10월 11일입니다. 그러면, 네, 월요일이, 네, 10월 11일이네요. Okay. So, can you see this slide, so chapter 1? So lab assignment is the assignment for the design labs, right? So I mentioned that the design lab is to design the simple RISC-V processor, okay? And then other assignment is for the some homework assignment. I will give some questions like some exercise questions in the textbook. So you need to answer these questions, and then you need to submit the answer to the Blackboard. So normal assignment is it's like the exercise questions, and then the lab assignment is the lab design assignments. Okay. So if you do not have questions, so I will move on the introduction of the chapter 1 of the course. Any question? Any questions? 네. So 녹화본은 so I will post the recorded video on the YouTube after every class. So do not worry about this real-time Zoom meeting. So actually the posted video, your videos will not be included in this posted video. So only this shared screen, and then this slide will be included in the posted video. So do not worry about the privacy on the public YouTube world. Okay? 그 수업 이후에 그 녹화본은 항상 그 유튜브에 올릴 거고요. 그래서 뭐 여러분들이 검색을 COSE222로 검색을 하면은 뭐 제가 사실 계속 올려왔기 때문에 뭐 저번 학기에 했던 강의도 볼 수 있습니다. 그리고 어쨌든 제가 줌을 점점 더 잘 쓰고 있기 때문에 그 수업 이후에 올라오는 이제 유튜브 비디오에서는 아무런 뭐 여러분 사진이라든지 아니면은 여러분 뭐 이거 비디오 있죠? 쉐어되는 거. 그거는 안 올라갈 거예요. 그거는 이제 없어지고 그냥 요 렉처 슬라이드랑 그다음 쉐어한 스크린 이 정도만 올라갈 거기 때문에 그런 뭐 프라이버시는 걱정 안 해도 됩니다. 오케이? Okay, let's move on. So chapter 1, the title of the chapter 1 is the computer abstraction. So I mentioned this terminology abstract in our syllabus. So actually in chapter 1, we will learn about the computer abstractions and then technology under our computer systems. Then another important topic is the performance metric of computer systems. Okay, so those are the three important topics we will learn in chapter 1. Okay. Okay, so computer architecture. So this is the computer architecture course. So in Korean, it is called computer 구조. So then, what is computer architecture? It's not easy question actually. So someone asked me, so what is your major? So what is your research interest? So I answered, oh, my research interest is in computer architecture. Then someone asked again, what is computer architecture? What is it? Computer 구조. So it's not easy to understand. No, it's not easy to explain. Okay. So computer architecture is the study on computer systems. What is the computer system? It's a computer hardware, and then the part of software that manages computer hardware. So this area is called the computer systems. So computer architecture means the study on computer systems. And what is the computer? So let us remind the object of the discourse. So what is the object of the discourse? Object of discourse is exploring computer systems or computer architecture. So what is the computer system? So this photo shows the very old generation of the computer system. That photo is the first generation of the IBM personal computers. So this is it looks very old, and you can find the very large computer hardware here, and then ugly monitors, and then ugly keyboard. So that is the very old computer systems. And then some years later, the Apple announced some fancier. So it looks better. So fancier computer system calls the Apple computer systems, like Apple III, or sometimes this Apple computer is so fancier than the IBM personal computer system. And then, so Apple designed some weird-looking computer systems like this. It's the MacBook Pro, and then it's the latest MacBook Pro. So this computer system looks like a cylinder, and then how about this computer system? So this computer system looks like it's cheese grinder. So very weird-looking computer system. So compared to the older generation computers, so this is fancier. it's a fancier. It looks fancier. Okay. So, but when we mention the computer systems, we do not only mention these desktop computer systems. So actually, in our real world, we use the mobile phone, like this mobile phone, and then we frequently use the smartwatches or smart speaker systems like Amazon Alexa. So these are also computers. So computer hardware. Yeah. 반드시. 잠깐만요. I'm sorry. 바꿔야 되겠네. Can you see the new slide now? Sorry about that. 예. 줌이 슬라이드쇼를 다른 걸로 인식을 하나 보네요. Okay, these are the very old generation computer systems. Like the first generation of IBM PC is called the personal computer systems. And then, so these are the recent computer systems designed by Apple. So it's a weird looking, but it's fancier than the old generation computer system. Okay. Yeah, fanci하죠? Everyone wants to have these fancier computers. Okay. And then recently everyone used the smartphone, and then sometimes we use the smartwatches or smart speakers. So these are also computer systems. So that means these devices include the CPUs, so central processing units. So actually, so we use the cellular phones before smartphone era. So we also use the mobile phone. But recently, we call our cellular phone is the smartphone. Why? Because this is a computer. So what is the computer? Why this is called the computer? Because computer can run software. What kind of software? General purpose software. So general purpose means 범용 in Korean. So if the device can run the general purpose software or general purpose applications, it's called the computers. So what does that mean? We can implement various types of software, various types of applications using computer languages. And then these computer languages or computer programs are executed on the devices or systems, hardware systems. And then these hardware systems are called the computers. So I titled this is the pervasive computer systems. So pervasive means the widely used, so widely deployed. So that means we use the computer devices or computer systems every day and every time. And then recently, we studied the domain-specific computer systems. So if we mention the computer systems, then we can mention the desktop computers, laptop computers, and smartphones. So these are the computers that includes CPU. But recently, we are using the domain-specific processors or domain-specific architectures. So what does that mean? This type of processors accelerate the execution of a certain domain of applications. So certain domain of applications. So something like games, videos, machine learnings, neural networks. So those are the a certain domains of our applications. So these domains are different from our normal applications. So something, for example, we can use the web browsers, or we can use the office softwares. So this is also some example of the different domains of software. But these domain-specific processors just accelerate a certain domain or different domains. Something like game, graphics, machine learnings. So recently, many hardware vendors or academia researchers are focused on these specific domain computer systems. So this is the GPU. So actually, we use the GPU for better gaming environment, but recently we use GPUs for machine learning applications or neural network applications. So that means GPUs can accelerate. So that means run faster. GPUs can accelerate the execution of these type of applications. So this type of processors are called the domain-specific architectures. And then gigantic computer systems. It's a cloud computer systems. So recently we used everyone used the smartphone, but our data exists in cloud computer system. So this cloud computer system is composed of many high performance computer servers. And then these servers are connected to each other. And then these servers work like one computer system. So the size is very gigantic. It's very large. And the performance is also very high. But we can use this cloud system like a one single computer hardware. So computer architecture also research on these gigantic computer systems like a cloud infrastructure or server systems. Okay. So computer architecture. Computer architecture is the study on computer hardware or computer devices or computer systems. And then this is very critical and very important because every electric devices include CPUs, or computer processors. And then these computers are widely used in our real life. And then it's everyday lives and every time. So that's why the computer systems research or computer architecture research is very critical. Okay, these are computers. And then these electric devices include CPU called like this. And then if the CPUs can run programs, general purpose programs, so that means those are the computers. Okay, so even this washing machine includes the CPUs. So computer is everywhere. So in the previous slide, so I showed some various types of computer hardware or computer systems. So we can also classify these different types of computers like personal computers and then server computers. So the type of computers are various. So it's diverged. So that means the purpose of these computer systems is also diverse. Okay, so that means so for example, if we developed these server systems, so what is the purpose of server systems? Well, cloud infrastructure. What is the feature of these cloud computer systems? So, okay, the high performance. So why high performance is required? Many users connect to this cloud infrastructure or cloud computer systems, and many users, so lots of users run their own program. So very large number of programs run on these cloud computer systems. So these cloud computer systems are designed for high performance and usability. And how about the these mobile computer systems like smartphone. So what are required for these mobile computer systems? What do you consider if you purchase the smartphone? 무엇을 고려하죠? 우리가 스마트폰 살 때? Speed. Speed means performance. Battery time, right? So actually this mobile computer system runs using electric power from batteries. That means energy efficiency is very critical. So energy efficiency means that for some workload, so it's the amount of energy required for executing a certain workload. So for this mobile computer system, power consumption, energy, and also heat, thermal are important design factors. So based on the purpose of the computer systems, these different type of computer system focus on the different design goals or design object or design goals. So for the personal computers like laptops or desktops, it's the general purpose. So that means it can run the various type of software or applications. And then, so this personal computer design focused on the cost performance trade-off. So that means this PC, the personal computers, need to guarantee a certain level of performance, because if we purchase some new computer system, then we want the better computers, like faster computers. Also, cost, money is important. Okay, and then server, like cloud infrastructure or cloud computer system is the network based, so it is connected to the internet. The high capacity because lots of users use this hardware system of the computers, this type of computers concurrently. So capacity, performance, and reliability are important factors of these server computers. Okay. And then supercomputers supercomputers are used for scientific computing or weather forecast, some drug development. So it's the highest performance. So it needs to guarantee highest performance, and the embedded computers like is power, performance, and cost. So energy efficiency is important. Okay, I have some questions. So this slide shows the different CPUs. Like, so this is the Intel Pentium 4, works with the 1.3 gigahertz clock signal. And then this computer is the Raspberry Pi 3B. And then this CPU of this Raspberry Pi works with the 1.2 gigahertz clock signal. So which processor is better? Can you answer? Which processor is better? Is a Pentium 4 and the Raspberry Pi ARM CPU. Pentium 4. So actually the clock frequency is very similar, 1.3 gigahertz and 1.2 gigahertz. So how can you measure? Okay. Intel is better than ARM. Okay. So which processor is better and why? Intel Xeon and the Intel i7. What is a Xeon processor? Xeon processor is used for server computers. and then i7. So it's a high performance CPU, and then it's a high-end CPU. So and then but the i7 is used for laptop and desktop computers. So which processor is better? Xeon or i7? Xeon. Because Xeon is more expensive. So what is the difference between Xeon and i7? Yeah, right. Depends on the tools, right? So we will learn about this performance metrics in this course about Xeon and Tesla, NVIDIA GPUs. Tesla is actually used for server systems, not gaming systems. So which one is better? Xeon or Tesla? Which one is expensive? Which one is more expensive? Tesla, right? Recently, NVIDIA GPU is more expensive than Intel CPUs. So actually, the Tesla is more expensive than Intel Xeon. So which is better? Tesla? It depends on the software type. So types of applications actually. So we will learn about the performance and then some various factors in computer hardware in this course. Okay. Okay. I will stop here. So 뭐 이제 줌이 약간 뭐 그런 에러가 있긴 했지만, 네. So do you have any questions? Okay. Okay, I'll stop here and then thank you for listening. Then see you the next class. 네, 뭐 수고 많았고요. 네. 어쨌든 이제 오늘은 첫 수업이니까는 이렇게 인트로덕션으로 이제 하고 뭐 다음 그 월요일에 또 이제 챕터 1 그걸로 이제 만나기로 하겠습니다. 네, 수고 많았습니다.